Hello everyone, welcome back to lecture second of week 8. So in the first lecture we have seen the definition of successive differentiation as well as some of the results which are already known and best well established results. Here in the second lecture of this week we will carry out those successive differentiation with more and more examples as well as the problems as well as some formulas. So some well-known functions like trigonometrical function, exponential trigonometrical function and so on, where we have to already knew that the nth derivative of such functions in the form of some known derivatives, right? So successive differentiation of trigonometrical functions and then successive differentiation of exponential trigonometrical functions and some standard results and then some exercises. So the first question is, as you can see here, this is the first question for successive differentiation of trigonometrical function, and the y is given in a trigonometrical function sine of ax plus b. We had seen in the previous lecture y equal to log of ax plus b, and then y of n has came out as in a very easy one, right? Similarly, here y equal to sine of ax plus b, and we have to prove that yn equal to an a p power n sine of ax plus b plus of n pi by 2, right? So we will do this by one. So since y is given, y1 can be calculated. What will be the y1? So y equal to sine of ax plus b, hence dy by dx, that's equal to y1 is equal to d of sine of ax plus b into dx. So this is equal to d of sine of ax plus b, and the sine x is known, so we have to use the chain rule. Dx. So this will be comes out to be cos of ax plus b, because argument are the same here. So that's why this is the cos theta only, and here it will comes out to be a. So this will comes out to be a cos of ax plus b, right? Now find y2. y2 is the same thing, differentiation of y1 with respect to the x. So it will comes out to be, okay, so this can be written as, since the answer is in the sine theta, so a into cos of ax plus b plus of pi by 2, right? And how we had reached to the conclusion? We knew that this is after, so this is all, this is sine and cos, this is tan, and this is, right, after school to college. So all these function with the from 0 to pi by 2, and pi by 2 to pi, only sign doesn't change the its sign, and tan has to be positive here and this one. So that is the idea. So cos of theta can be written as sine of theta plus pi by 2, right? So here we had written this one, cos of theta has been changed as theta plus pi by 2, sine of theta plus pi by 2. Similarly, taking y2 is equal to what? y2 equal to a square cos of ax plus b plus pi by 2, right? So this will gives you a square sine of ax plus b plus of 2 pi by pi, that is only pi, right? Similarly, y3 you can find out, and then yn. So yn become a p power n sine of ax plus b and plus of n pi by 2, y4 and so on. So yn become a p power n sine ax plus b p power plus of n pi by 2. Now if a equal to 1 and b equal to 0, y equal to what it will given? It will given sine ax plus b, right? See, so if I put a equal to 1, and b equal to 0, y becomes sine of x. So yn become sine of x plus of n pi by 2. That is a good result, right? So if y equal to sine x, y of n is nothing but sine of x plus n pi by 2. X plus n pi by 2. Similarly, we can evaluate yn equal to cos of ax plus b. Then y equal to cos of, this is the y, right? So y equal to cos ax plus b, then find out yn as an cos n ax plus b n pi by 2. This is the similar to the sine one. We had seen that sine y equal to sine ax plus b leads y of n as a pi power n sine of ax plus b plus of n pi by 2. So in the similar manner, y equal to cos ax plus b also leads to the a pi power n cos of ax plus b plus of n pi by 2. How to do this? Use the similar method and convert this cos into sine and sine into cos. So y equal to cos ax plus b. So y1 equal to a minus of a into sine of ax plus b. Sine of ax plus b can be written as cos of ax plus b ax plus b plus pi by 2, because sine of theta is the same thing as cos of theta plus pi by 2, right? So that's why y1 can be written as a into cos ax plus b plus pi by 2. Again, using the y2 is equal to a square into cos of this, and it becomes sine of this, right? So a square sine ax plus b pi plus pi by 2, and this will become, so as you can see here, we have cos ax plus b, then minus of a sine ax plus b. So this can be written a into cos of this. So if I want to find out derivative of this, so this is the same thing, constant is a only. So taking the constant outside, so minus a into a and sine ax plus b, so sine ax plus b plus pi by 2. This will become a square of cos ax plus b plus of 2 pi by 2, right? So this is the pi, right? Similarly, y3 and y4 and then yn. So yn become a pi power n cos of ax plus b plus of n pi by 2, right? This is your answer when y equal to cos of ax plus b. And putting a equal to 1 and b equal to 0, that means if y equal to cos x, yn become cos of x plus n pi by 2. And we had seen in the previous result that if y equal to sin x, yn become sine of x plus of n pi by 2. So both results are very similar and very close to each other. The approach is very close to each other on a very similar line. Now explore for exponential trigonometrical function. That means function contain the exponential as well as the trigonometrical functions, right? So this is the complex function, and we will going to derive its nth derivative. So if y is given e pi power x sine bx plus c, then y1 become, so what will then find yn, then find y of n, right? To find y of n, firstly let us evaluate y1. So what will be the y1? So y is given x sine of bx plus c, right? So this is the two function. This is u and this is v. Now let me change the color first. So this is u and this is v. Now y equal to uv, so y dash is equal to u dash v plus of u into v dash. That's we knew, right? And that's why y1 can be written as here. So this one will be equal to u dash e pi power x u. So u dash is equal to a into e pi power x, right? Into sine of bx plus c, and plus u that means a pi power x into v dash sine bx plus c. We had seen right now here Sin ax plus b is nothing but it will give you a into sine of ax plus b plus pi by 2, right? Using the same formula here, or you can write down cos of bx plus c into b, right? So using the all those things converge here, all those can accumulate here. So here you have aex sin x sin bx plus c, the first term, that means this one, and then b into ex plus b, that means this term, right? Is it okay? So now we had seen that y1 equal to this. Now it has the four terms. In the first of this term, we have the two terms, right? See, and then in the second term we have the again two terms. So now imagine how much terms are going to updated or a stock up when we find out y2, y3, y4 and yn. To digest these things or to minimize the calculations, we have to find out some in a different form. So ax plus b can be written as, or something putting by a equal to r cos theta, b equal to r sin theta, leading the whole function in a polar form. So here introducing a equal to r cos theta and b equal to r sin theta, r square is equal to a square plus b square, right? So a square become r square cos square theta and b square equal to r square sin square theta. So a square plus b square is nothing but r square, because cos square theta plus sin square theta is equal to 1. So this will be r square, right? And tan theta equal to b divided by a. So tan theta, that means sine of theta divided by cos of theta, that can be written as r of sine theta divided by r into cos theta. R sin theta is equal to b by a. So tan theta is equal to b by a, and r square equal to a square b square. Now use the same thing and convert this y1 in terms of r and theta. So here a become a equal to r cos theta. So r into cos theta, e power x is the same one, sin bx plus c, and here b is equal to how much? B equal to r sin theta. So we have r and sin theta. Taking r as a common and e power x as a common, we got sin bx plus c into cos theta and cos bx plus c into sin theta. Now use the sin theta, sin a cos b plus cos a sin b, right? Sin a cos b plus of sin b cos of a, right? So that will give you sin of a plus b. This will give you sin of a plus b. So using the same thing, this will give you r into ex into sin of the sum of this a plus b. A is equal to bx plus c into plus theta. So this will be the same thing. So now y1 has came in one term now, r into ex into sin of bx plus c plus of theta, and we knew the answer how to deal with this y1. So y2 is equal to r square ex sin bx plus c and plus of 2 theta and so on. So this will comes out yn become rn e power ax sin bx plus c plus of n theta. That will be a good result of this complex functions. Similarly, we can evaluate y equal to e power x cos bx plus c and its nth derivative. So what will be the nth derivative? Using the same thing, introducing a equal to r. So a equal to r cos theta and b equal to r sin theta. This will lead to r square equal to a square plus b square and tan of theta equal to b by a. So now y1 become in a one term, and then using the same approach as we have done in here, y1 become in one term now, this one, and using the same approach here, yn become r p power n e p power x, r p power n e p power x. See, r p power n e p power x sine of this. So this will be r p power n e p power x cos of bx plus c into n theta. So that will be your answer. And if you want to elaborate this question, just find out y1. Y1 become what? Y1 become r into ax into cos of bx plus c plus of theta, right? And similarly, what will become y2? Y2 is nothing, as we have seen that if it is in the form of cos of bx plus c plus something, then use just n pi by 2, right? So using the same thing, it will becomes out to be r square e p power x cos of bx plus c plus of 2 theta. That will be your answer. Similarly, if you find out y3, that is equal to rq eax cos of x bx plus c plus of 3 theta. And if you are doing the same thing, then yn, as it is written, rn e p power x cos of bx plus c plus of n theta. That will be your answer, right? Now, all those from the first lecture and this lecture, we have summarized the whole results so that it will be easy to recognize or recall it, right? So I strongly suggest you that you have to go through your notes, you have to go through the problems, and you have to write down on your paper. Since mathematics is not something you have to just memorize it. After some time, 1 or 2 days, you will just forget it. So that's why what you have to do, you have to just try to evaluate yourself. Once you do it, it will be in your mind. So memory will be a strong one once you will do yourself. So evaluating and doing the problem yourself will be the most constructive things in mathematics. So reading the mathematics or learning the mathematics is one of the easiest thing when you are constructively write down in your own words. So here is the summary of the results. We had seen y equal to eax in the first lecture, and that was the answer is yn equal to how much? A p power n e p power ax, y equal to ax plus b p power m, that is equal to polynomial. And what will be the answer? Y of n equal to factorial m divided by m minus n factorial, a p power n ax plus b m minus n, right? It is only happen when m is greater than n. There were 3 cases. If m equal to n, the whole equations will come in a very easy way, factorial n into a p power n, right? And when this is minus 1, m equal to minus 1, that means y equal to 1 divided by ax plus b, then the answer will be minus 1 p power factorial n a p power n divided by ax plus b n plus 1, right? And if m is greater than 0 and m is less than n, then nth derivative is going to be 0. We have seen for I think y equal to x to the power 5 and y of 6 is equal to 0, right? We had seen this one. So in a similar manner, if y is a logarithmic function log ax plus b, then nth derivative of this logarithmic function is minus 1 p power n minus 1 factorial a p power n ax plus b p power n. Similarly, y is in a trigonometrical function sin ax plus b, then yn equal to a p power n sin of ax plus b plus of n pi by 2. And if it is in the cos, then use the cos instead, and the result is almost look like a similar thing, very matching to each other. E p power ax sin bx plus c, or yn is nothing but the different way, e p power ax a square plus b square n by 2. here a square b square is written as r square, right? So our result in the previous slides, as you can see here, in the Rn can be converted in a square plus b square as r square equal to a square plus b square. So r power n is nothing but a square plus b square or n by 2, right? So that's what here written. And sine ax plus b plus of n into theta. What was the theta? As you can remember here, theta is nothing but tan theta equal to b by a. So theta equal to tan inverse b by a. Using the tan inverse b by a, you will find out the answer. Similarly, ex cos bx plus c. Now change this one. Ex r square is the similar one, and then in place of sine, just change cos, and all those things are similar. So only changing sine to cos will result a nth derivative of sine to cos, right? Using these results, can we find nth derivative of a given function, which is the sum of the two function y equal to sine pi power 4x plus cos pi power 4x, right? So in the previously one, we have seen that if exponential trigonometrical function is in the form of e pi power x sine bx plus c, yn can be written easily as Rn e pi power x sine bx plus c plus n theta. And as well as in the summary, we have seen that if any function in the form of sine bx plus a, that is y of nth, that means the nth derivative is a pi power n sine ax plus b plus n pi by 2. So using these results and keeping in mind all those results, we can find out the nth derivative of a given complex function y equal to sine pi power 4x plus cos pi power 4x. So y equal to sine pi power 4x plus cos pi power 4x can be written as sine square x plus cos square x ka whole square minus of twice into sine square x into cos square x, right? So this means we have a4 plus b4. This is nothing but a square plus b square whole square minus of 2a square b square, right? So sine square x plus cos square x is what? Is 1. So this is 1 minus of half of sine square x into cos square x will become sine square 2x. So sine square 2x is equal to 1 minus of cos 4x divided by 2, right? This will be the trigonometrical, very famous trigonometrical answer, trigonometrical derivation. So now y can be written as, here y equal to half of sine square 2x. So using this one, we can use this 1 minus of y equal to 1 minus of half of sine square 2 of x. So this will be 1 minus of half into 1 minus of cos of 4x divided by 2. So this is equal to 1 minus of cos x 4x by 4. So this will be 4 minus 1, that is equal to 3 plus of cos of 4x divided by 4. Now we had to find out into 3 plus cos 4x by 4 as a y, So we can find out the answer because we now have this result, sine ax plus b cos x1, right? So y equal to cos ax plus b, that is equal to yn is equal to a pi power n cos bx plus b plus of n pi by 2. Using the same results, you will get directly the answer, that is equal to yn is equal to 4 pi power n minus 1 into cos of 4x plus n pi by 2, right? So that is your nth derivative of the solutions, nth derivative of the given function, that is y equal to sine 4x plus cos power 4x. Now can you imagine if I am not using the formula, how much I have to calculate? Looking at this questions itself, you will see that each time you have to find out another 2 terms, see here, then another 2 terms, then another 2 terms, and it's a stack up. and once it accumulate, you will find out in the nth derivative very big problem. So to simplify and to contain in the same results in a very specified manner, the results are useful. So I suggest strongly that you have to memorize these results so that given any questions, you will be able to find out the solutions. Look at the example number 2, and it is open for you, and can you find out the answer? So y equal to xq eax. So it is exponential function and algebraic functions as well, and find out yn. So using the two function y equal to xq ex, so here u equal to ex and v equal to xq. Now this ex is nothing but it's not ex but eax, right? Eax. So we knew the answer. If u equal to eax, we knew the answer u of n equal to how much? A power n into e power ax, right? And v equal to x cube, we knew the answer as well, right? After third, that means fourth is going to be 0, fifth is going to be 0, and so on. So that means we knew the answer of v equal to xq as well. So using, I mean, the product of the two is not y equal to uv is not like this, because y1 will give you u into u dash into v plus of u into v dash, right? So somehow we are looking for something y of n equal to uv n. So we are looking for two functions of x and their multiplications. So uv, nth derivative of the uv, and such a thing is will be explored in the next lecture, where we will going to prove Leibniz theorem. This is the problem of Leibniz, and he has started this problem, and he has derived uv nth derivative of u into v, where u and v both are the continuous and differentiable function n times with respect to its argument x, right? So using that one, you will get this result. So we will explore in the next lecture Leibniz theorem. Leibniz theorem is nothing but it is the nth derivative of a two given function, multiplication of the two given product of the two functions u and b, which are itself continuous and differentiable with respect to the x. So thank you so much.